ARPA Toscana. He will show us experience in Firenzuola tunnel. He has another important tunnel in the Apennines in central North Italy. Okay, this is chemical analysis of composition of water from our way tunnel. It is a back analysis because there are some impacts on the springs and streams due to the construction of this tunnel, and then we have this project just to better understand the mechanism of these impacts. And we are in Tuscany, and we are the old railway built in 1930 crossed the Apennines here, and the new railway built finished in 2009 crosses here the Apennine chain. And the geological pattern of this area, we see that Firenzuola terminal that is here costs mainly elastic turbulence formations, as we can see in the geological section. This is the Firenzuola terminal that crosses mainly atmospheric formation, and in the central part of the tunnel, the most part of the impacts on springs occurred. So this is our study area. Marnosa formation can be sketched as alternating of sandstone and marsh layers, and in some areas layer thickness is up to some decimeters, and in other cases layer thickness is up to a few meters, and there is a high sandstone or marsh layers are sometimes impermeable, instead sandstone layers have orthogonal fractures that allow a water circulation limited to a single layer. But there are also faults and water system fractures, discontinuities, that allow the water circulation on a wider scale. Here there is a very sketch of groundwater circulation in the last 30 meters. From a determinate height, we have all the fractures filled with liquid water. And but I look on the impact due to the construction of the tunnel. This is a very illustrative sketch of the effect induced by tunnel drainage. That in case of high permeability, we have piezometric surface connected to the tunnel, and so a very high lowering of the water table. And this is an example of the impacts. We have this stretch of the tunnel built from Southeast Wingo towards north. This stretch made a fractured belt, not forecasted during the design, that caused an inflow. And here we have the seasonal trend of the spring. Here we have flow rate units per minute year. We see the seasonal trend, but at the moment of the tunnel we have an impact, and so the spring was dried, and so for the aqueduct we have to find other sources. There are several examples in the Firenzuola tunnel due to the fractured belts. They are like tabular and subvertical aquifers, not connected or very low connected from each other. And they cause the drawdown of the piezometric surface and then impact on the springs, but also on the streams. Because if we have a persistent drink on the upper basin of one stream. In some cases, like Fossor-Ambuldi, we have drying when we meet a fracture belt that connects the water stream to the tunnel. Here is a couple of examples of tunnel inflows. This is an inflow of 150 liters per minute in the tunnel. And here we have in the southern stretch of Firenzuola Canal, we have the flow rate, the discharge of the tunnel, and here the year of construction. We can see that in the most part of in most cases we have a correspondence between the water inflows and the impact on the surface, on springs or on streams. But there are some cases like this that we have water inflows, but not apparent, not evident impact on the surface. So we have to study this also with geochemical and isotopic characterization. This project was carried out with the collaboration of National Research Council, and just to better define hydrogeological paths and better defining and comprehension of impact and possible trend in the future, and have more data for the planning of mitigation works. The most part of the project was done between 2004 and 2007, and this is the study. The red dots and the red lines, the red dots are impacted springs, the red lines are impacted streams, and in orange when we have an uncertain impact. We make chemical analysis on major ions and isotopic analysis. In particular, the useful was to study the tritium content of the water collected in the tunnel. Here we have in red the point, the sampling point. So we have at the end of this project, we have a lot of data, over 700 samples, a lot of analysis. So we could discuss the data, and for streams we have the chemical classification that show bicarbonate calcium phasures. Similar phasures for springs except from two wells, but they are quite far from the tunnel and in a different hydrogeological basin. In the tunnel, instead, most part of the drainage waters have bicarbonate calcium phasures, but except the samples from the central part of the tunnel that have instead bicarbonate sodium phasures. So we try chemical correlation, and we see that there is a sort of water maturation from calcium sodium ratios, high calcium sodium ratios to low calcium sodium ratios. In effect, in the central part of the tunnel we have a low calcium sodium ratio. In tritium is an unstable isotope in the half-time of 12 years. So you use this for discriminate short circulation water from long circulation water. And in this diagram we have the tritium content here and sodium content here. And in this case too, we have the central part point of the tunnel that have high values of calcium and low values of tritium. We try also to evaluate the residence time, but there are linguistic difficulties. So, but we try to apply some models, and then the main result is that it is possible that these relatively old waters then are captured from the central part of the tunnel have residence times larger than 50 or 100 years, depending on the assuming model. So now we can subdivide the tunnel into three sectors. We have here the water inflows during the digging of the tunnel. Here we have the calcium sodium ratio, and here we have the tritium content in 2004 and 2007. And so in the northern area we have substantially rapid infiltrating of meteoritic waters, so we have high values of tritium. In the central part of the tunnel we have a high value of sodium and low values of tritium, particularly in this point. We have here a member of the Monroe-Ranascia formation that is reaching Mars, and so it constitutes a low permeability barrier to the infiltrating of rainwater towards the tunnel. And the southern stretch of the tunnel there is a sort of mixing of old water and recent water. This hydrogeological subdivision is confirmed also by tests carried out by other authors that didn't find any direct correlation, a connection between the tunnel and artificial waters with the central section of the tunnel. We have in this movie, here there is Firenzuola tunnel, but we have an older tunnel here of another railway excavated in 1890, and in the same fish formation of the Firenzuola tunnel, the same Monroe-Ranascia formation, same characteristics. And we plot the sample of this water, and the southern side of this old tunnel, it shows that in the calcium sodium diagram, values are reliable to in quite old water. So the same thing occurs when we plot it in tritium sodium diagram. So we have nowadays at the southern center of the tunnel, more than 100 years after construction, the persistence of this old water. So there is really a long path of circulation that feeds this water. So we can expect that the same thing occurs in the Firenzuola tunnel. I go back to Firenzuola tunnel. We collect additional samples 2 years ago, and that is a mixing of several water inflows around the tunnel, because now the railway is active, so it's no more possible to collect this single entry point. But this sample shows a chemical feature that is halfway between more and martial water. So we have we confirm that we are in presence of a significant contribution of long circulation water. So isotopic mechanical methods allow good identifying of the groundwater circulation. The central part of the tunnel, waters below low tritium content are part of the long path circulation. And nowadays the framework of impact and water flow rate of the tunnel can be considered as stable as we can be we can see from the results of this study. Thank you.
Thank you very much. This is a very interesting feedback from big impact, hydrogeological impact in railway tunnel. Are there any questions?
Ad Antonio ha mentioned the tunnel as a taking part from the base flow of rider from the base. And just a question about the whole gallery.
The whole gallery?
The whole one that you showed it. The whole one from 1890.
Yes.
What showed this gallery? There are some records about the overall flow.
We tried to find it, but it's not easy. But we tried to have someone, so we had no result. We had to interest historic
much more.
It's not.
With your option 18, where you try and calculate the price of concentration?
I'm sorry.
With the option 18?
Okay. No, because we have a short distance between the infiltration area and the tunnel area. We have the infiltration area of the meteoric water at about
What's the difference?
300 meters. 400 meters, so it was not possible to have a certain discriminate. So we didn't have a result in this process. All the sampling point plots along the line of meteoric water, and then we will not have any. No, I don't know that.
Yeah, what was the difference then in the electricity value of the springs? Did they have a early shift in the function 18 values and towards this? Could you see a difference?
No.
I think one of the most important things is the trying to extension of the impact top, of course. So we do that stabilized condition.
Yes, we think so.
Could you I deal with measurement or measurement that is slow down?
Yes, it is not only from the chemical and isotope analysis. We carried out in 2007, 2008, and furthermore in 2012, geochemical analysis, isotopic analysis, measures on stream flow or spring flow, and in some cases on this. So we didn't see any changing from the end of the construction that was 2006 to 2007. So
How long do you take
in 7 years,
get this into stable conditions? How long does it take to get these stable conditions?
we have 7 years. So it was substantially stable conditions.
So the impact was quite fast.
Yes, well, quite fast. We see that along this fractured belt, we have in the near the tunnel, what is about some 100 meters, we have a few days. And in some points, about a couple of kilometers, we have about 3 months, 3 or 4 months. But Yes, okay. This is a good question. The first time it was decided to have 2 years to monitor how but with the Regional Council we decided to extend this monitoring for some other years for selected points, critical points, but we decided. So we have just in the next week we have just 5 or 6 measures just to confirm some residual dust.
Yes, if I may make a comment, what is very interesting is that you have a sort of quick integration of pressures, but then it needs many years for a real equilibration of the system, and we see this with chemical analysis, because you are changing, you have equilibration during years to coming from the mixing of different systems. It means that you can have generally wide impact with pressure, which is given after some time. But then it's not the real equilibration of the system.
Yes, because you can see here there is sorry there is we have impact very fast, but the water discharge of the tunnel, see here, this is the end of the period of the construction of the time, and we have here the pressure curve that arrived at about 2006, 2008. After 2008, so after 2-3 years of the end of the construction, and we have a normal development.
So what's the flow rate now?
The flow rate now is reached by system is about in the southern stretch 100 liters per second, on the north stretch is about 150.
Is there any of these springs which impacts drop efficiency and flow now?
Only some springs. Only some springs, but during the season have some water, but during the season there is not.
Okay. Yes.
At least a couple of years.
But this we see even in the deep ones. So in this first deep tunnel we made 10 kilometers with one person following, we see a fluctuation. There are flow of 60 to 80 meters, and it's even the materials. Yes, you can even see this. I think it's very important to notice now also years, because today's experience you really can say, okay, we have the opportunity to monitor even 5-6 years later after we finished the tunnel construction. This is important. Yes. Because you can see always that there is a level.
Yes.
Flowing or flow, even therefore level in the head.
It's quite amazing. I mean, you have no sorry, the previous
Okay, so I think we can close the discussion. Thank you very much.